These are notes for Honors Math 3, Unit 6 on conic sections. This is Objective 5, which is a new lesson on ellipses. So this is ellipses day 1. We start at the top with the definition of an ellipse. You can see their picture here. An ellipse is a set of all points in a plane whose distance from two fixed points, the focus points, is a constant sum. You can see those focus points here. So like a parabola had a focus point near the vertex, you're going to see two focus points near each vertex here on each ellipse. So depending on which axis is longer, so is the x-axis longer or the y-axis longer, we'll have a different equation. And you'll notice it's actually the same pieces. The only thing different is where a squared and b squared are. They've swapped places. You want to note that a squared is always going to be bigger than b squared on ellipses. And so wherever the bigger number is that you see, it's underneath the longer axis. So here you'll see the bigger number on the bottom underneath x. That makes x the longer axis. Here you'll see the bigger number under y. That will make y the longer axis, which we actually call the major axis. So although it's written, everything is squared in here, and you'll also want to notice that each equation is set equal to 1. That is the standard form for the equation of an ellipse. So a squared, if we square root that, we get a, which is the distance from each center to vertex, center to vertex. And so 2a is the length of our major axis. We square root b squared to get b, which is centered to each co-vertice, which we won't really identify or anything, but we will need it in order to make an accurate sketch. And so 2b is the length of our minor axis. To find the center to each focus point, c, it's the focal length. It's a different formula here than it was for the parabola. So c is the square root of a squared minus b squared. So it's always just the bigger number minus the smaller number, square root that value. The last thing you'll find is something called the eccentricity, which is really just how round our ellipse is. So that number will always be between 0 and 1. It's a ratio of c, the focal length, over a. So we've got c, center to focus, over a, center to vertex. So a smaller number over a longer number is always between 0 and 1. The closer it is to 0, the more it starts to look like a circle. Okay? The closer the number is to 1, the more stretched out the ellipse will become. So those are all ideas that you'll want to keep in mind. And these are characteristics that we want to find when we're working on these. So in our first problem, we're going to do just that, all of the things here. We're going to rewrite it in standard form. We want to identify all of the characteristics, and then we want to sketch. So like with circles, the first thing we want to do is group our x terms, group our y terms, and we complete the square for the x's and the y's. We'll go ahead and move 16 over to the other side. And we might need a calculator for a few things here and there. So we're going to start by grouping our x's. All right, we'll group our y's and add 16 over. In doing that, in order to complete the square, I actually need to factor out my leading coefficients. So I need each of them to just be a 1. So I'm going to factor out 21 from the x terms. We're going to factor out 5 from the y terms. And inside each, you'll leave room to complete the square. So we'll start with the x's. We know -2 plus -2 is -4. -2 times -2 is +4. And while it may seem that we just added 4 here to the left side, remember that we factored 21 out of not just these two terms, but also 21 times 4, 84. So we actually have to multiply it by 21. In order to add to the other side and keep it balanced. Remember, if I distribute this 21 back out to what it was, then what I really had here was an 84. So I want to balance by adding 84 on the right as well. we do the same thing with the y terms. So 1 plus 1 makes 2. 1 times 1 makes 1. So what I'm adding here is actually a 5. So I want to balance by adding 5 over to the right side. All right. So you've got this 21x minus 2 squared plus 5y plus 1 squared. And over here it looks like 105. All right, so how do I get it to look like that standard form? And why isn't this a circle? So we'll see x and y are both squared. They're both positive as well, but they have different coefficients. And that's what sets this apart from a circle and makes it an ellipse instead. We have different coefficients here. So in order to get this into standard form, the last thing you want to do is make sure you are equal to 1. In order to set this equal to 1, we have to divide everywhere by 105. All right, so 21 over 105, we reduce that, x minus 2 squared over 5, plus y plus 1 squared over 21 is equal to 1. And there we have our standard form for the ellipse. You can still see, even from this point of view, that we have different coefficients. So 1/5 and 1 over 21 are my coefficients. So we want to identify now the center. So I have h and k, so 2, -1. Then we want to start finding the vertices, and we want to start building our sketch. So I'm going to go ahead and plot the center. Just a little dot there. So what I want to do, remember, I can always identify the bigger number. You don't have to really worry about knowing that it's a squared or b squared. It's really just about the bigger number or the numbers matching up to the value they're underneath. So 5 matches with x, 21 with y. And really, remember, everything in here is squared. So this is really root 5 squared. And this is really root 21 squared. That value that's being squared, that's the value that will move from our center to plot our other points. So root 5 is the value under x. So along the x-axis, we want to go root 5 units. That's right and left with the x-axis. So root 5 is a little bit more than 2 units. So root 5 units from my center, root 5, a little bit more than 2 units to the right, a little bit more than 2 units to the left. Along the y-axis, that's up and down, we want to move root 21. So that's between 4 and 5. All right, so from here, we want to go up 1, 2, 3, 4, a little bit more than 4, less than 5. So about here, that's one vertex, because it's going to be the bigger number is going to be along the longer axis, and at the ends of the longer axis lie my vertices. Okay, so also from the center, we want to go down 1, 2, 3, 4, 5, more than 4, less than 5. That's going to be my other vertex, and so I can connect these to make the ellipse here. All right, so that's my sketch. Now I want to identify the vertices. So this is tough because we went up and down root 21 units. So rather than trying to get a decimal approximation and figure out what those numbers are, we're just going to use the center. And notice that they have the same x value too. We keep the same x value too. And what we do is we adjust the y value, because from -1, we went up root 21 and down root 21 units to get to those vertices. So we take -1 and we both add and subtract root 21 units to get to those vertices. And so that is the location of them exactly. All right, so to find the focus points, which also lie along that major axis up and down and inside the ellipse, we're going to use C, the focal length here, which is the root of the bigger number minus the smaller number. So we're looking at the numbers underneath here. We want to use the square numbers, 21 minus 5. And so we get 4. All right, so that's not so bad. So up and down 4 units. So I could do this the same as I did with center. Up 4 units, down 4 units. So they have the same x value, 2. And then we adjust the y value, -1. We add and subtract 4 units. Now you can't leave it this way because you can add those together as like terms. So you want to simplify. -1 plus 4 is 3. -1 minus 4 is -5. And we list them as 2, 3, and 2, -5. The length of the major axis, so that's going to be center to vertex, center to vertex. So remember, each center to vertex, that was the root 21. So if we have root 21 plus root 21, or if we just double root 21, we have 2 root 21. We do the same for the minor axis. It was root 5 to the right, root 5 to the left, so a total of 2 root 5. And then last, the eccentricity is just going to be the values of C over A. So the value of C is 4. The value of A is root 21. And with a decimal approximation, you could see that that number is less than 1. So that is how we want to go through rewriting in standard form. Remember to make sure that your equation is always equal to 1. Identifying your characteristics. We have a new formula for focal length C. And then length of the major and minor axis, you just want to double the values that you used going right and left. Eccentricity is C over A. Okay? So I have one more example for us to go through. And this one's just going to be a little practice with writing the equation. So often a picture will help to get us started, just so that we understand which way we want it to move. So center at 0, 0. My vertices are at 10, 0, and -10, 0, with focus points at 6 and -6. Focus, vertex, vertex, focus. So I can imagine then it must be longer along the x-axis. That's going to be my major axis. And I can start building this in. So x minus 0 squared over something plus y minus 0 squared over something is equal to 1. So along the x-axis, we have from our center here, center over to one vertex is a length of 10. So that is the number that I need to square, and I write underneath x. If you'll remember, that's kind of backwards of how we found it in example 1. 10 squared, that'll give me my value here. So what about the y value? So we don't know this distance here. Instead, it's something that we'll have to solve for. And we're going to do that by using the focal length formula. So C was equal to the square root of the bigger number squared. So 100 minus b squared. This number that goes here is b squared. And that's what I'm looking for. Now C, my focal length, center to focus, is 6. So we can just solve this and figure out what our number is supposed to be here. So 36 is equal to 100 minus b squared. And so b squared must be 64. And that is the number that goes right here. So my formula now, x squared over 100 plus y squared over 64 is equal to 1. All right, and we'll do more of those in the next few days.